Hi guys, today we're going to be talking about some conditional probability. We're going to walk through some notes together and then some examples, and then you'll have time to work on some yourself. So the first thing is we want to come up with kind of a working definition of conditional probability. So here's where we're going to kind of live. So given I have two events, and we're going to call these A and B, just two different events. Conditional probability is the probability of an event B, the second thing, occurring. Know that A has already happened. Okay, so we're going to assume that A has happened and then figuring out kind of what the probability of B happening is, and we'll look through some examples. So there's a special way that we can write this. So what this looks like is we're looking at the probability of B that A has already happened. Okay, so that's kind of how we're looking at it, and we read it as this. We read it as the probability, and I'm going to just abbreviate probability just because it's easier for me to handle. So the probability of B given A. That's how we would read this notation, is the probability of B given A. So here's our formula. So again, we want to use our correct notation. So we're going to say that this is the probability of A and B, and then we're going to divide that by the probability of A. Because that has to have happened in order for B to happen, so that's why we have to kind of add that little piece in. So let's look at a couple of examples. Let's look at example number 1 right here. So Mitchell drew a card from a standard deck of playing cards. So one thing we have to remember that when we're dealing with playing cards, there's always 52 playing cards. Okay? There's 13 of each different suit. So just having those things in our mind, just knowing that that's true will always kind of help us a little bit. Okay, so we're using that standard deck of playing cards. We're looking at what is the probability that he drew a queen given that the card was red. So first we want to figure out, I'm going to look at queen, and that's going to be blue, and then I'm going to look at red in red because I can, right? And then we're going to look at the whole kind of the order in which we're going to do these, okay? So, we drew a queen given that the card was red. So that is going to be kind of our B piece. So that's the first thing that has to happen. So we're going to look, whoops. So I know that the number of cards that are red is 20. There's 26 out of the 52 cards that are red, right? Because half of them are red and half of them are black. So we're going to say that that was the first thing that we did. So knowing that that was the first thing, right, so given that the card was red tells us that's the first piece. So that's also going to be the denominator of my whole big fraction and ratio that we're looking at. And so those are the ones that are red. And so then I want to figure out, okay, so how many of them are queens? Well, I know that there's 4 queens, and we're still looking out of this 52 card deck. So I see here that this is going to be my setup. So now that I have this, I'm going to go ahead and actually kind of simplify and get rid of all of the fractions within fractions. So this is, I'm just going to kind of look at this part and give you the answer, but if you look at this and you're totally stuck on how to simplify this kind of a complex fraction, come see me and we'll do a couple real quick. So I know that once I go ahead and multiply these out, I end up with 1 over 13. So that's the chance, the probability that I will draw a queen given that the card is red. Okay, so let's look at example number 2. So a number from 1 to 100 is randomly selected. So that gives us kind of our sample space, right, our sample size. So what is the probability that it is a perfect square given that it is an odd number? So first I want to figure out what are my odd numbers, okay, and we're looking at 100 numbers, and I know that half of them are odd because the other half are even. So then I know I can look and I can calculate how many of them are perfect squares, and in this case there's 10 of them that are perfect squares. So there I've got all of my little pieces figured out, so I can go ahead and simplify this whole fraction and come up with 1 out of 10. So that is the probability that I select a perfect square given that it's an odd number. So I want you to try these next couple of examples, and I will post the answers for you so you can just double check that you're correct and right. So I want you to try them first. Okay. All right, so the next thing we're really going to look at is two-way tables. Okay, so two-way tables are a different way that we can have our information. And this did not come across really cleanly when I opened it this way. So here's kind of really my definition of a two-way table. So it is a table that records data that pertains to two different categories, right? So two ways. So here in this table, I see I've got one piece of data is if it's a boy or a girl. The other piece of data that I'm dealing with is preferring hockey or football. Okay, so that's my example table that we're looking at. So the table shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find the probability. So here's where it's kind of funky. It did not come out nicely. So let's look at A first, which is down here. So A, we're looking at the probability that they prefer football, given, right? Remember, that's what that line means, that that is a girl. So here's how I can kind of figure it out. I can literally just use my two-way table. So I see prefer football and girls. That would fall into this category. And then I notice that this piece tells me that it's given it's a girl. So I would only calculate this number to be my denominator. Okay, so I would end up with 6 prefer football, and there were 22 girls. So that can simplify, right? Because both 6 and 22 are divisible by 2, so it would end up being 3 out of 11. So that is my probability that this person, that this randomly selected person prefers football, given that they are a girl. So you can see how sometimes this two-way table is just a little bit easier to find our probabilities because we don't have to do all of the crazy fraction dealing with. Okay, so let's look at this B part. Ooh, and I changed color. There we go. So now we're looking at the probability that it is a boy, given that they prefer hockey. So I'm looking given that they prefer hockey, so it's this group down here, and the probability that it is a boy. So I would end up with 10, because 10 of these boys are in this circle, and out of the people that prefer hockey, there's 26 of them, which again, I can simplify this fraction to 5 over 13, so that would be my final probability there. So it's a little bit easier using these two-way tables. So let's go ahead and do this example together, and I'll walk you through this whole example number 5. So I've got this table that shows the results of 150 randomly selected middle school students who were asked if they take French or Spanish. Okay, so now we have to figure out our probabilities. So I've got my probability that of a 7th grader who takes French. So I'm looking at all of the kids here because I'm not told anything that they're given something. I can just look at probability that we're dealing with a 7th grader who takes French. So I know that there were 150 students, and there are 25 7th graders who take French. So that would end up being my numerator. Okay, so then I can simplify this. 25 goes into 25 one time, 25 goes into 150 4, 5, 6 times. So there's our probability. So now here in these next examples, now we're getting into that conditional probability a little bit more. So let me go ahead and erase this. Okay, so now we're looking at we have a probability of an 8th grader given that they take Spanish. So I want to look at this column here and looking at an 8th grader. Okay, so I see I have an 8th grader and taking Spanish. I'm going to add up all of the numbers in that column here. So I've got 23, and so 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6. So 33 out of 68, that would be my probability. And I would ask myself, well, can I simplify that fraction any further? And I can't, so I can just leave it there. So then we're going to look at the next piece. So I'm looking at the probability that they take French given that they are a 6th grader. So given that. So I see I have 19 of them take French out of the total number of 6th graders, 12, I've got 42. So then I again ask myself, can I simplify that? And for this one I can't, so I can leave it there. All right, so then our final little piece, using this table of data, I want to look at if I have a 7th grader, given that they take French. So I'm looking at now this column and a 7th grader. So I see I've got 25 out of, and then I would just add my values in this column and end up with 82. Okay. And again, that can't be simplified at all. So now here's another example that you can go ahead and work through. Just see if you can kind of follow what we did up here with our two-way table and kind of follow this one, and I'll post the answers for you. So the next really thing we're going to look at is some frequencies, and this gets a little bit more funky, but we kind of have to understand where these words come from. Okay, so our joint relative frequency is the value in each category divided by the total number of values, and that's kind of the key thing, is the total number of values, okay? And that's our joint relative frequency. So let's look at that, and then we'll look at our marginal frequencies. Okay, so the table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. Find the joint relative and marginal relative frequencies, then find each probability. So how that's going to work is first we got to kind of fill out our table and finish that up. So first we want to do is figure out how many total people there were. Okay, so when I go ahead and I add all of these together, I see I have 160 total people that we looked at. So then I can take that information and figure out my probabilities and continue filling out my table. And to continue filling out this table, you are going to want a calculator because this is not stuff you're going to want to do in your brain. So I see that my joint relative frequency is the value in each category divided by the total number of values, which we found right here is this 160. So to find that out, I'm going to look at first class first, because it doesn't really matter what order. Well, I see I have 16 people here divided by 160 gives me 0.1. Well, and then if I do 12, my 12 people with 1 bag divided by 160, I have 0.075. And then 0 bags, I had 2 people divided by 160, which would be that 0.0125. So now let's look at coach class. So I see here I've got 52 divided by 160, 0.325. Then I've got 60 divided by 160, which gives me 0.375. Then I see for the 0 bags, I have 18 divided by 160, which gives me 0.1125. Okay, so those will be our joint relative frequencies. So then we can find our marginal relative frequencies. And in order to do that, we just total each row and column. So if I add by going across for 2 bags, I end up with 0.425. Again, if I add going across, I end up with 0.45. And going across, I end up with 0.125. Okay, so now if I add going down, I end up with 0.1875. And again, adding down here, I have 0.8125. And you will know that you're correct in all of this, because if you were to add this column going down or this row going across, you will end up with 1 right there. Okay, so now let's use this to help us find some of these probabilities. So I'm looking for the probability that I have a coach class passenger that did not check any bags. So I see that I've got a coach passenger that did not check any bags, which would be right here. So here I'm not looking at this conditional probability, remember, because I don't have that line. So I can just go ahead and say that my probability was 0.1125 or 11.25%. So we're going to be going back and forth now between decimals and percents, so make sure that that's something you're kind of comfortable doing at least. Okay, so now let's look at C. I'm going to let you try B and D on your own, so I want to try C with you before we just start trying those. So I want to find the probability that I'm looking at coach class given that they checked 1 bag. So I'm going to be kind of looking in here, but I'm looking at coach class, right? So again, I can look at this whole thing and kind of help me use this to have this two-way table help me figure it out. So I know I'm looking at the coach class, which is 0.375, given that they checked 1 bag. Well, and we've already done our combination there, so we've already added and combined those values. So I can just use that part, that marginal relative frequency, and divide it there. So once I do that, I end up with 0.83 continued, so approximately 83%. Okay, so I can use this two-way table to help me kind of find my different probabilities. Okay, so that's really it for this whole section. So I'm going to go ahead and work through these examples and post them